Alright, I'm parked in a space. We got hours to burn. It's dry, it's sunny. There will be traffic distractions. It's a bright, dry autumn day at the moment. It's meant to be rainy, but it's not. Let's see if we can work our way around this somehow. Squeeze my memory sponge. Astronomy is the topic for today. I've had many dealings with astronomy. I never got fully into it. I suppose every kid in some way gets into astronomy because you just go out, you know, at night, the stars are there. Sometimes they're quite bright and you can see all this stuff up there, all these scattered points of light, and they're all different brightnesses, and some of them are twinkling, and some of them seem to move, and some of them you're told by people are not even stars, and you're like, what? And then obviously the moon, and then you're told the moon is kind of like the Earth, we're on a sphere. Sorry, flat earthers, it's not going to be a video you'll like. Car. So I don't know how young I was when I began getting into astronomy stuff. I think I was not that young. At one point, I think my dad bought me a telescope. When was that? It must have been in the 90s. Let me see now. Mid-90s, maybe? Long time before that, Dad had binoculars. He'd always loved using binoculars. Maybe they gave him some during his army days and he took a fascination to using those. But at some point in the 90s, I was given this rather plasticky, I'd say, telescope. It wasn't a metal telescope. It was like hunks of plastic on a plastic tripod with, you know, all the lenses and mirrors in the right place. I believe it was just the standard reflector telescope, which is like an L shape. So you look it down in the eyepiece and then it's a tube, a big tube shaped thing going outward. And mine was silver and black with a white tripod, I remember. That's a reflector telescope where it's in that L shape, where it's simply like look down and then the mirror bounces it across. And I think you twist the knob and mirrors inside the tube get further and nearer to each other, which enhances the image. It doesn't zoom, it's focusing. And the other kind of telescope you can get, I think, is called a Schmidt-Cassegrain, which is it's not an L shape. You've got a bigger tube. I think they both have like pros and cons, but this one is a better one. I never had one of these. It's a bigger tube and the eyepiece is facing the same way as the tube and it's just off to the side sort of thing. So it's quite an interesting design. So that one's more like binoculars, but one eyepiece is massive and one eyepiece that you actually look down is tiny. The first one's not an eyepiece. So never got to play with one of those, but I saw it. At some point, Dad got me an astronomy book, which I still have, which is a really nice astronomy book. And actually I have a couple. I don't know which one I got first. But there's this big one, this big chunky hardback one. And it's by one of the two discoverers of the Shoemaker-Levy comet. I can't remember if it was David Levy or the other one, Shoemaker. The Shoemaker-Levy comet is a comet that people saw smash into... I can't remember if it was Jupiter or Saturn now. This is embarrassing. Was it Jupiter? Anyway, it was like a once in a lifetime experience where this big astronomical thing was happening, where a comet got sucked into the gravity well of one of our gas giant planets and hit it. And people could observe on the surface the glowing line of marks where this comet had crashed into this huge planet. So that one of those two guys that first saw that was the one who wrote this hardback book that I have. We're talking about astronomy. That's why I like ultra zoom cameras. I've just seen a plane. Ultra zoom cameras remind me of my first telescope and the fun I used to have being able to zoom in on distant objects. I think I used to try and see birds, but they move so fucking fast. There's a cloud in front of the plane, but it's drifting quite fast, so I might be able to see it. I just got it before it went in the cloud. It wasn't a max zoom shot. Oh, I can do it in the editing room. If I have a picture of the front of the book that I have and the name of the author and the which planet the comet smashed into. I believe it was Jupiter, but for something in my mind is saying, was it Saturn? I don't think it was Saturn. I think it was Jupiter. This trail of comets hit. Anyway, that book was a brilliant book. I've still got it now. It explains like the basics of the universe as we knew it in the 90s. I think they added a bunch of shit, which, you know, you don't really know what's true and what's false with scientists, because with scientists, real scientists, not the COVID type of fucking scientists who are paid by government to push propaganda, real scientists actually go on theories. Everything's a theory and nothing is set in stone, and you can disprove a theory if you have evidence that there might be another rival theory that can debunk it that is a better one to go with. Modern day scientists pushed by leftism and governments do not understand this concept, that science is about questioning and curiosity. It's not about superiorism and calling yourself an expert and placing you above another human and saying, I've got an academic study, so I am correct and you are incorrect. That's not what science is about. So back in the day that I was learning about astronomy, I think before that I would have learned about dinosaurs and all that. So like really basic building block history, not deep history, not anything other than a kid's understanding of it. But I knew about like dinosaurs and all that. And so I had a basic idea of time. And when you start learning real astronomy, your concept of time is sort of messed around with quite a lot, because I think like a day on Earth is completely different from a day on Mars and a day on Venus and a day on Mercury, and a year is different on each planet as well. And sometimes I think it's possible for a day to be longer than a year for some planets, because I think it's to do with the spin, the rotation of the planet. Yeah, it is, versus its orbit around the sun. So the rotation of a planet denotes its day. The orbit around the sun denotes its year. So you could have a planet that is just physically spinning slower, but it would zip around the sun maybe because it's really close into the sun. So Mercury, cyclist. Mercury travels super fast around the sun, so it has, I believe it probably has the shortest year out of all the planets. But it might have a different, like a much longer day than we expect. Because some of these nuggets of knowledge, I know the concept of them, but I haven't memorized the statistics, so I don't know the exact number of what it is. So you start learning, you're like, wow, look at all these things, just these little random facts. You just dip in random facts about the universe and you just extract something which sounds exciting because it's like mind blown, I never knew that. And you sort of read it out of order at first, I think, and then as time goes on you kind of read it in order, like what should I know first, what should I know last. So you start off by picking out these little facts, like, you know, a year and a day is different on different worlds. How does day and night work? What are the names of the planets? Where are the planets? What are the sizes of the planets? How did they even get to be there? Are there other planets outside the solar system? What is a star? It turns out the star is the same as our sun. And you get that in your mind and you're like, well, okay, so one of the stars is really close to us, and that's how we get our day and night. And all these tiny little pinpricks we see when it's night, they're just more suns. And there's just lots of little incredible things you learn, like the temperatures on planets, the power of the wind on like Uranus and Neptune and Saturn. Like incredible windstorms that you could never get away with on Earth because we're just so small. The gravity wells of things like Jupiter, like it's an enormous planet, part way to being sun size. I think it would have to be, it depends on the sun, because then you get into like the sizes of suns. Like, so Jupiter could be bigger than some suns. Obviously it's the biggest planet in the solar system. Order of the planets is something that every kid should know, I think. the main ones, like I think 8 of them. You can choose whether or not you want Pluto. Most people choose Pluto to be part of it, but it's just uncharacteristic. It just screws up with their order because they like there to be 4 rock planets, then 4 gas giants as you go out further in the system, so it kind of disrupts it if there's a 9th planet that isn't a gas giant. I think people, like scientists, don't like that for whatever reason. But there's actually tons more beyond Pluto. Planetoids, I think, just much smaller rocks and things. And Pluto's so small that it's on the verge of being just one of these floaty rocks, I think. People affectionately like Pluto to be called a planet. I think that's fine. So, nearest to the sun, you got the sun in the middle. You got the heliocentric view, which is the Galilean view that all the planets orbit and circle the sun. They spin on a great kind of record player disc, and they're essentially falling towards it, but missing it. And that's how people describe gravity. They're trying to fall inward to the sun, but, you know, they end up going in these circles because they can't actually get to it. Next from the sun, you have Mercury. It's a tiny rock planet, very hot on one side, very cold on the other. I believe it has no atmosphere. I think the sun's like ripped it off. And you have Venus, which is our neighbor. Venus is one of the 2 bodies in the solar system because you have to count moons. Some moons are like planets. The moons of Jupiter are like their own planets, but they don't go around the sun, they go around Jupiter as if it's their sun or something. And our moon goes around us, obviously. Around Jupiter, there's a moon called Io, which is a bit like Venus in a lot of ways. But yeah, going back, Venus is the 2nd planet of the solar system. It's like an embodiment of hell. The Russians actually sent spacecraft to land on Venus, and because of the intense pressures and heats of the planet, these metal spacecraft just melted very soon after sending pictures back to Earth. Melted into a big slag pile of useless metal. So we have pictures from the surface of Venus. But it is like hell. Like, you don't want to ever go somewhere that in a few minutes will just melt metal just by being there. But Venus is also used by idiots on Earth to get away with enviro-communism. The whole environmental thing of global warming and the ozone layer and all this stuff, like, oh my god, climate change is destroying the planet, oh my god. A lot of that comes from Venus. Venus, I believe, has a lot of CO2 in the atmosphere, and it's got these giant clouds that obscure the surface from anyone, let's say, in orbit or looking at it with a telescope. You cannot see, like if you were to look at Earth, you could see the surface of Earth between the clouds. If you were to look at Venus, the whole thing is just cloud. The sun does kind of get in through the cloud, and then this is something about clouds. Clouds trap heat, so they say it's got a runaway greenhouse effect. Greenhouse effect is a little bit of propaganda, but it's also like the concept that if you have a greenhouse on a summer's day, which is a glass house, it's trapping the sunlight in there to an extent. So once you step in, it's boiling hot compared to the outside. And that's basically the greenhouse effect in a good way of describing it conceptually without going into political propaganda. And so Venus is that, basically. Instead of having glass that keeps the sun in, it's got cloud layers. They're quite thick. So it's quite surprising how much sun can actually get through them to the ground to become trapped, but it does. And so the clouds have kept this furnace between the sky and the surface. And I think part of that is to do with the makeup of gases that are there. Next on from Venus is obviously the Earth. We're the only ones that we know of, still to this day I believe, where there is life in the solar system. We have not found life on other planets, and people are always really fascinated by the fact that Earth is the only planet with all this varied wildlife on it, and plants and humans, of course, to create what we call intelligence sometimes, which sounds dumb in hindsight. But yeah, animals with membrane bodies that move around and have autonomy and go looking for fuel to self-sustain their existence for a temporary time. This is what we are, and this is how we even got to the stage where we can look up and think about where we are, and astronomy and geography and such. So we're constantly on the lookout, not only for stuff like us, but obviously for animals and the much lower organisms. We'd even, like, I think people got disappointed that they can't find man-like beings or aliens or animals on other worlds, so they'd just be happy if they found some bacteria at this stage, single-celled organisms. There have been lots of scares over the year, or almost discoveries, where people think they have found bacteria, like fossilized, on Mars, but it's not proven. It all just seems like a bit of a red herring, a goose chase, and nothing real, like some etches in a rock that looked a bit like a worm, but, you know, it just could be what the rock is like there. It's not really a proof of anything. So, I mean, we all know what Earth is like. With Earth, our days are dictated obviously by our spin, and we're familiar with that number, and the year and the month is dictated by the moon. We've chosen our time scales to be based on these things so we can keep track of time as it goes on. Not that that matters these days, because people don't give a fuck about their own history, but yeah, we use it to plan things, like plan our week, plan what we're doing, like Monday, Tuesday, Wednesday, next month, next year, next 5 years. So that all comes from astronomy. Our next neighbour along from us, which seems always more appealing to us than Venus, which is hell, is Mars, which is a cold, dusty world, very similar to our own, smaller than the Earth, whereas Venus is almost the same size as the Earth. I'm not sure whether Mars or Venus is further from us, which one of those two is the further neighbour from us, but people have always been fascinated by Mars. Can't remember if it has an atmosphere or if that got stripped out. No, it does. It has an atmosphere, I believe, a very thin atmosphere. It's got lower gravity than us. Obviously, I'm a big fan of War of the Worlds, so there's always been this fictional view of Mars in the past, which is what that book was based on. And lots of different fictional ideas of aliens come from Mars. A lot of the planets are actually named after like Greek gods and things, and Mars is like the god of, I think Mars is the Greek god of war, or is it the Roman god of war? Either Greek or Roman old mythology. It's mostly Greek. Like star constellations and things are named after mythological Greek heroes and things. I think Jupiter is a god, Mars is a god, Venus, I believe, is a god. You get lots of these names. I've got to wait for horses. So people always thought Venus was very, hot and boiling and unforgiving, but we look over to Mars and we think, hey, well, maybe there's a chance we can land down on this neighbour, because I don't think we're going to manage to do it on Venus. And then there's the moon too. So the moon and Mars have always been the top candidates for human space travel, like our first planetary colonization. Obviously there are a lot of conspiracy theorists who are correct, I'm going to say. I'm not going to denounce conspiracy theorists, because that's been a recent thing in the past 5 or 10 years. That's a thing from the political spheres, to say someone's a conspiracy theorist or not, to say what truth is meant to be or what science is and what is true and what is false. That entire thing is political now, so it's not worth talking about. But there have been the so-called conspiracy theories that we didn't land on the moon, like flat Earth, and I don't mind those folks. They can believe whatever they want. It's not what I believe. I believe we did land on the moon. I believe that to be a reality. Then again, I believe in contrails. I don't believe in chemtrails, except for specific examples like the Vietnam War and such. And I'm undecided about the 9/11, the September 11th attacks on 2001, whether that was Osama or whether that was US government. There's compelling arguments for both now, to be fair, and I think we pick our conspiracy theory and we have a look at the information backing it and we decide for ourselves these days. Of course, talking about astronomy, the original conspiracy theorist for me was Galileo, and I like to call myself a Galilean conspiracy theorist because he was put under house arrest, I believe, for the latter part of his life by the Catholic Church for daring to push his belief that the Earth went around the sun. Many years later, he was vindicated. After his death, though, sadly. Of course, I think the Catholic Church and a lot of the astronomers at the time before him believed in, I think it's called the Ptolemaic system, where they thought everything went around the Earth. Like all the stars and all the planets, the sun, they all went around the Earth, which was the center of the universe. The heliocentric model that Galileo found was like, no, we're not so arrogant to be the center of everything. Actually, it's the sun. They didn't like that. So if I'm a conspiracy theorist, I'm a Galilean conspiracy theorist. But yeah, I don't believe the moon landings were faked. I think we actually got there and landed on it. So let's lay that to rest for my view of things. Your views may differ, and that's fine. I also don't believe in God, but all the astronauts who landed on the moon, to my knowledge, did believe in God. So I find that quite fascinating as well. One thing about if you wanted to create a colony on the moon, you could create moon glass. Because the lunar sand, that white sand you see, the regolith, which I think is actually weirdly sharp and can actually cut through like parts of your spacesuit and things, which is kind of worrying. It's like this sharp-grained fine powder. You could turn that into moon glass. Obviously, glass is on Earth, it's made from sand. So if you go up to the moon, you have this resource that you can build moon bases out of, part of your moon base out of, which is if you can get up there and make a factory, you can just take the sand off the moon and refine it into glass, and then you've got part of your building materials up there. Maybe you could even dig into the rock and smelt the ores or whatever, the rock, to make metals. And, you know, like on Earth, you've got ways of building your buildings. So there's a lot of interest in planets for their mineral resource as well, obviously. Minerals and mining and making metals and things from resources is something on Earth which gets a lot of money moving. So there's that. It was always fascinating seeing the history of the space race on Earth because it was powered by the wars and the Cold War between America and the Soviet Union, and also the German World War II rocketry and missile programs. So they were creating rockets to launch at Britain and such. You know, in past wars in the 1700s, you know, where you had all the coloured coats, the Renaissance soldiers and the line battles, things like rockets and missiles did exist, but they were very sparse in their use. They were very, like, unuseful as weapons. They'd use them like they use artillery. So more commonly they'd use a cannon and fire cannons over at the enemy, fire cannonballs, and that got refined into artillery shells as time progressed. And they'd also try and do that with little fireworky rocket things, fill them with gunpowder, fire them at the enemy. But these things were chaotic. They'd be caught in the wind, they'd do twirls, they'd fly all over the place. So it was more of a scare tactic on the battlefield, I think, than like a formidable weapon that actually did proper damage. So, you know, I think it took until like World War II Germany, unfortunately it was the Nazis, they started building rockets and firing them places and started refining that technology. And so you find that a lot of rocket scientists that joined NASA were actually ex-Nazi. Or they came over from Germany after World War II, and so there's this weird connection between NASA and Nazis, which I didn't know for the longest time in my life, but once you look into it, you're like, oh, okay. That's where a lot of the useful ex-World War II Germans went, science-wise, is they went into America for the space program, and they used them to help build rockets And that's how the Americans got their rocket technology. And then obviously we went head to head with the Soviet communists in Russia, and there was the space race, which is between America and Russia. No other countries really got up to the levels of those guys. And, you know, during the Vietnam era, which was still the Cold War, it really took off, quite literally. Russians were putting the first man in space, the first dog in space. They were trying to get over to Venus. I think they even had some landers on Mars as well. And Americans never got to Venus, but they put landers down on Mars and the moon. And then we had the manned moon landings, which occurred in the 60s and 70s. And we never really went back again because we gained safety culture, where people were averse to risk and didn't realize that in order to do something like the age of exploration, you have to have sacrifice. You know, people will need to die in order to go up there. You know, if you want to climb Everest, you might die. I think Brian Blessed probably talks about some of this stuff because I think he went up to Everest, and you have to think in terms of, like, if you're gonna explore the bottom of the sea, the deepest trenches like the Mariana Trench in submarines and things, you have to expect that you might die doing that sort of thing. The sea is probably worse than space, actually, as somewhere to explore. Exploration has always gone hand in hand with risk and freedom and self-sacrifice, knowing that you might die doing it, but doing it anyway. Once we gained this kind of safety culture from the 80s onward, a lot of people just started not doing much in space, not really getting out there. I think there was the Challenger disaster. There was lots of space shuttles and spacecraft that blew up, killing all the crew, and everyone got all scared and started going, oh, have you filled in a risk assessment? Like, we shouldn't be sending humans up into space because they might die. Oh, it's terrifying. Why do we keep sending astronauts up there? They're all dying. We can't do that anymore. We've got to keep everything safe if we do it. And so everything slows down and your space race just dies, basically, until Elon Musk comes along with SpaceX and it started again, which is pretty cool. Yeah, everyone's tried to get to the moon and Mars. Other candidates further out for colonization, the next planet along, after of course the asteroid belt, because so the next planet is Jupiter. Between Mars and Jupiter is the asteroid belt. Also, I think following Jupiter in its orbit is something called the Trojans, which is just a gathering of asteroids on the same orbit, but not in the same place as the planet. So Jupiter is itself not really a candidate for colonization because it's a giant ball of gas and wind. But because it's so big, it has its own little solar system. It has moons surrounding it. And the moons are quite interesting. Io you wouldn't want to go to because it's like Venus, it's like hell. I think you might be able to see the surface from space though. I don't think it's hell with the cloud layers and the atmosphere, but its ground is like molten chemicals and stuff. I think it's because it's so close to Jupiter, the bigger planet is able to mold and squish the rock surface of Io. Like, I don't know, constantly squeezing and unsqueezing a sponge made of rock, which produces a lot of heat. Then you've got, so there's 4 main moons of Jupiter, but there's actually tons more than that are smaller. Io's one of the big 4. Europa is one of the big 4. Callisto and Ganymede. Ganymede is a great candidate for having a colony. Probably one of the best candidates in the solar system, I think. Europa is very special because it might have liquid water actually underneath the surface. It's mostly like an ice moon. So it's like an ice moon where the crust is ice, and then under the crust people forecast that there's probably water lakes just underneath. Ganymede's just a ball of rock, but that's quite useful and it's quite large. Callisto, I think, there's something up with that. It's more chemical in makeup. It's a ball of rock, but it's got like jets of some unknown liquid that fire out of it, like gas volcanoes, or maybe even liquid volcanoes. It fires out these plumes from it, as far as I remember. And then you've got all these much tinier moons that orbit Jupiter. But if you've got a telescope and you point it at Jupiter, and I've done this, depending what day you do it, some days are better than others, you can see the moons. You can see the Jupiter show up as this big bright yellow star, and then you can see like 4 dots in different places around it. I think it's best when the 4 dots are like lining up, like there's 2 one side and 2 the other, or there's Jupiter and then all 4 are on one side of it, sort of thing. Because you have to imagine they're like spinning around Jupiter like a record, like a vinyl record or a CD or something. Obviously beyond Jupiter you've got Saturn. Saturn is iconic because it has these gigantic rings around it, like its own asteroid belt essentially, of ice and rock. And it's always been fascinating to look at, and it's fueled lots of imaginations for space travel, just to look at Saturn. It's ice with high winds. It does have several moons of its own, again, to explore. There's one called Titan, which I think is quite fascinating. You look at it and it's like a weird green and yellow lens thing with, it's got seas made of like a weird gas. I can't remember, is it like methane seas or something? Or petrochemical seas? Yeah, it's really weird. I think we've landed on Titan, but we've sent machines to land on Titan, so I think we actually have photos and things of it. And there are a few more moons there. I can't remember. I think Enceladus is one. Maybe I'm confusing Enceladus with Callisto back there with the chemical or liquid plumes that come out of it like volcanoes. And then after that, the next planet along is Uranus. Yeah, I had to get that right. Sometimes I get it mixed up between Neptune and Uranus being the last big gas giant, but Uranus is the next one near Saturn. Uranus and Neptune are very similar to each other. One of the two is like bowled over on its side, so it spins like, you know, our pole is at the top, our North Pole is at the top of Earth, and our South Pole is at the bottom of Earth, and our equator's in the middle spinning around. I think with either Uranus or Neptune, the equator's like going along top to bottom sort of thing, and the poles are on the sides, which is really weird. Both are greenish blue, both are incredibly windy. Uranus and Neptune, it's very difficult to differentiate between them both. One of them, I think Neptune, has a spot on it. I should go back to Jupiter and say it's got the big red spot, which is this feature that everyone knows. This red windstorm, like a permanent tornado on the surface of Jupiter. Neptune's got a little white version of that, but it's tiny. Both are incredibly high winds. Both have rings, I believe. I think Neptune's rings are more easy to spot. Between Neptune and Pluto and further out, you have the TNOs, the trans-Neptunian objects, and that's how I know Neptune is the last gas giant of the solar system, because you've got these TNOs going around that come in past the orbit of Neptune, and then they also go out of the orbit of Neptune. Also, either Neptune or Uranus, the orbital path of one of those two planets, it might be Neptune, is like skewed from the disk of the solar system. So if you think of the solar system going around the sun, all those planets going around the sun as a vinyl record, imagine taking a donut off the very edge of that vinyl record, snapping it off the record, and just tilting it while keeping the sun in the center still. And you've got various rocks and things between Pluto and Neptune and beyond Pluto that are smaller than Pluto, that we don't consider as planets, but we might as well, because they're basically the same thing. They're rocks spinning around the sun, and they have all sorts of crazy orbits, some of them even madder, that don't necessarily follow the disk around the sun. And then you've got Pluto, which people are very affectionate about, but it is just another ball of rock. It's tiny, and then all the other planetoids are tinier than that. Heading out away from Pluto, which is basically the last planet of the solar system, you reach various edges of the solar system. No one has a defined edge of the solar system. You've got something called the Oort cloud, which is a sphere of rocks around the solar system. You've got the heliopause and the heliosphere, which are like the sun's magnetosphere, which deflects gases and random horrible objects from the galaxy at large from coming in. And then that's our solar system. And you have to think that each sun, each star you see in the night sky is just like that. Each star is like our sun with our planets going around it, and this heliosphere, heliopause, heliosheath is another part of it. These are all detected by the Voyager 1 and 2 probes, which are the spacecraft that got the furthest from Earth. They're the furthest spacecraft that we've sent out, and they're just like trying to leave the solar system right now, and it will take them fucking years and years to do so properly. That's how far everything is. We can probably build a lot faster spacecraft now to maybe overtake them, but no one's trying it for real. So yeah, each star out there is a solar system, and all the nearest ones form this thing called the galaxy, which our galaxy is the Milky Way, and I'm sure you've seen pictures of a galaxy, bright ball with these white, creamy, light blue twisty arms full of stars. Most well known is the one we're in, the Milky Way, and then another well-known one is Andromeda. And then when you look out between the stars and your telescope, your home telescope will not be able to see any of these things very well. Well, firstly, you can see nebulas, which are little fuzzy areas, which if you took a photo of them, they look quite colourful. These are big gas clouds just out there, floating between the stars. They're enormous, some of them. But you can see other galaxies from our galaxy. Like from the Milky Way, we can look out and see Andromeda. That's a very famous one, like a neighbouring galaxy. I think it's bigger than ours, but it looks small. And then if you have super powerful telescopes, which the average Joe at home doesn't have, you can look between the gaps of the stars. And if you look up, if you go and search the ultra high def, something like the UHD, ultra high def astronomy images of galaxies, or is it high field, ultra field, something like ultra high def field, UDHF, something like that, where they just picked a patch of black space between the stars and used a super telescope on it, and then enhanced that image and zoomed it in, and there was thousands and thousands of these galaxies in, each containing thousands and thousands of stars. I should say millions, really, and each star containing a whole solar system. So it's mind-boggling, the scale of everything when you look out there, that it's just impossible that we can be the only life in the universe. That's just, you can rule that out completely. I think it's called the Drake's equation. It's just really obvious when you look at how many things there are out there, that humans and animals on Earth are not just some fluke that can't be repeated anywhere. These things, just as there's thousands of different animal species on Earth, there's thousands of different animal species, like millions and billions out there. A lot of it as smart as us, or way smarter. They're probably out there right now building ships and trading and things, and we just can't see them because our technology is so shit for looking at things happening far away. Everything we do to look out at space is based on optics. Again, more fascinating things you can learn about the universe, like the speed of light. It's the fastest thing we know, and yet it's finite and it's kind of slow, and distance conquers the speed of light. So it takes years and years and years for a ray of light from, say, a sun or a planet to reach us over the vast distances in the universe and the gulfs of space. And as a result, when we look up at a star, we're seeing the light from it finally arriving in our eye after having travelled for many, many years and years and years. And as a result, what we're seeing of the star is the past of that star. We're seeing the history of the star. We're not seeing it as it is now because that light hasn't arrived yet, and it won't arrive until the far future. So in the far future, we'll see what the star is like right now. We're always seeing like a collage when we look up at the night sky of different histories of different stars. Like you might look up at one star and see it appearing now to us how it was 40 billion years ago, and look at another star and how it appears now to us is how it was just 10 years ago, and they'll be like right next to each other, so they'll just look the same as each other, but we're just looking at this weird, like, it's hard to get your head around what you're looking at in the night sky. You're looking at different time slices in different spots. So yeah, it is truly amazing, everything you can learn looking in a telescope at the night sky or learning about astronomy. And because it's such a dense topic, I'm probably going to leave it there because the video is too long, and my god, get into astronomy just for the fascination of the physics and just knowing there's these, like, I don't know, like a lot of astronomy is optics. I think a lot of astronomy is to do with sight. There's nothing really up there necessarily to do with sound. A lot of it's to do with sight, a lot of it's to do with space, scale, geography, and time. And just mixing all those things together, it really messes with your mind and overwhelms you, sort of in a fun, exciting way. It keeps you thinking a little bit like a child, but, you know, beware that scientists will always try and use things against you, so be careful when looking at the information. Try and work out what's real and what's not real based on your own experience and based on how people explain things to you about how they've worked this out and what they can show you. Because once you see things with your own eyes in telescopes and things, you can believe, like, there are moons going around Jupiter and they're orbiting it, and they're in different places each night, and there's 4 main ones, and you can see them change position, and you can see how Jupiter moves compared to the stars, and know that you know, if you look out on a starry night and you see 2 really bright looking stars, the brightest ones in the sky, that's probably Venus and Jupiter, because Venus is the closest to us, and because of how it looks, it reflects light really well with that cloud surface from the sun, and it often follows the sun down at sunset and comes up with it at sunrise. So that's how you know that's probably Venus, is it's near the sun at sunrise and sunset. Jupiter is just massive, and again it reflects light really well. So that's the brightest object in the sky apart from the moon and the sun, of course. It's bouncing a whole shitload of sunlight back at you, so it just looks like this yellowy gem, brighter than all the other stars. And stars will twinkle, but planets will not, generally. Anyway, there's so much I could tell you, so much you could learn yourself, but for the childlike wonder of it, I recommend getting into it. And for proving it to yourself that this is real, get into like the optics, look through telescopes, and keep an eye on how people are explaining astronomical things to you, because some of it may be bunk, some of it may be false, some of it may be theory. A lot of it may be a theory with a lot of evidence to back it up, so it's probably a good theory and is probably real. So that's a tiny piece of my understanding of astronomy. For me to tell you everything I know about astronomy, this was one video. This would have to be 15 videos long, I think. Maybe 16. So I'll probably not do that. Anyway, catch you all later, folks.